Hello. Now today in this session, we are going to solve some examples on what we have done by now. I'm sure you all must have been tired just reading the theory all the time, that various terminology we used. We used absolute value, then we had some inequations with absolute value in their standard form and their solutions. So let us try today some more examples on that. So my first illustration is that absolute value of x minus 4 upon x minus 4 greater than 0, and I'm given some 4 options which are again in the form of inequations. Now absolute value of x minus 4 upon x minus 4 greater than 0, if I had to start with, then my first observation is that absolute value of x minus 4 is greater than 0, which is appearing in the numerator, and the entire quantity absolute value of x minus 4 upon x minus 4 we want to be positive. So the only option I have right now with me is that numerator positive, that means denominator also will have to be positive. So I have with me x greater than 4. So now actually the solution set of the given inequation is absolute value of x minus 4 upon x minus 4 gets satisfied by the values all which are greater than 4. And now if I have to apply this set of values of x, I will have to see which of the inequations of those 4 options get satisfied. Now my first inequation is 2x minus 5 less than 1, which is very simple. You can take 5 on the other side. That means you add 5 on both sides and then simplify it to x less than 3. So first inequation gets satisfied only when x is less than 3. So obviously x greater than 4 does not satisfy this. I go to next. That is absolute value of x less than 4, which is of the form x between minus a and a. Solution set was minus a and a. So here we will say minus 4 to 4. So obviously even this inequation does not get satisfied by x greater than 4. So we go to next, which is of the form absolute value of x minus 1 less than 2. Form absolute value of x less than a. We know where the solution lies. So it would be x minus 1 between minus 2 and 2. Now add 1 on 2 sides and I will get x between minus 1 and 3. So third inequation gets satisfied by the values of x which are between minus 1 and 3, not by greater than 4 region. So obviously this inequation is also discarded. So the only option left with us is the fourth one. So please let us not jump to the fourth without calculating. So just spare some few more seconds and try to justify it. That x plus 3 whole square is always positive except at minus 3. And if I am going to take the region x greater than 4, then I realize that minus 3 is outside. So x plus 3 whole square will always be positive. And the product x minus 4 into x plus 3 whole square will be again positive. So the last D option gets satisfied by all the values of x which are greater than 4. The correct option is D. So by taking this one multiple option question, actually I'm trying to emphasize on the fact that we are not going to just randomly answer. We have to actually work out and then come to the conclusion like how we did in this one. So I go to next, and that is absolute value of x minus 2 upon x plus 3 less than 1. Now this is not like previous one. So your first immediate reaction to the sum could be that I will multiply by x plus 3. No, don't do that. We do not know what is the sign of x plus 3. I mean whether x plus 3 is negative or x plus 3 is positive. So please do not multiply just like that. It's better that you take two different cases. So I take my first case as x plus 3 less than 0. If I take x plus 3 less than 0, then what happens? I can multiply x plus 3, but I will make the sign change and I get absolute value of x minus 2 greater than x plus 3. Now mind you please, x plus 3 we have taken negative. My case is that. That means absolute value greater than a negative quantity we are getting, which is always a true statement. Means all those x which we have considered less than minus 3 type, they all are going to be part of our solution. So we realize that x less than minus 3 will be part of solution set. Now we go to next and take second case as x plus 3 greater than 0. Now if I take x plus 3 greater than 0, am I not free to multiply by x plus 3 on two sides? Yes, I will not bring any sign change and I get absolute value of x minus 2 less than x plus 3, which is clearly of the form absolute value of x less than a. And we know the solution. Solution was between minus a and a. So I will have x minus 2 greater than minus x minus 3. And the another case I will have x minus 2 less than x plus 3. Now these are two simple inequations which you know how to solve, and try to get condition on x. And I get condition, first one as 2x greater than minus 1, and the second one I get as minus 2 less than 0, which is always true statement. And mind you please, between we have written and. So second part actually is not disturbing us at all. The only part which is of our interest is 2x greater than minus 1. And this leads to x greater than minus half. X greater than minus half lies in the region x greater than minus 3. So my second case solution is x greater than minus half, the common part of both. And now I club inequation named as 3 and 4, and I write my final solution set. And that is minus infinity to minus 3, union minus half to infinity. Mind you please, everywhere we have written round brackets. Round bracket means open intervals. Nowhere inequality was in the form of less or equal to. So nowhere square brackets we have used. So the only solution part is minus infinity to minus 3, union minus half to infinity. So the correct option is A. I think this question was different from the previous one. But one thing we have realized, we have to be alert while solving inequations. So let us go to next and take third one. And third one is absolute value of x minus 2 less than or equal to absolute value of x plus 4. Okay. Now, this is neither of the form absolute value of x less than a, nor it is of the form absolute value of greater than a. So, the standard inequations what we have studied, they are not immediately of our help. But something we have learnt there while deriving their solutions, and what step we had taken. We had squared on two sides. And can we square in this case? Yes, we can square. Why? Because both the sides are positive. So what I do, I start squaring on two sides and see what happens. The simplified form of the inequation would be that I get 12x greater or equal to minus 12. So on simplification, I will get x greater or equal to minus 1. So the solution set is actually minus 1 close to infinity. And question says that we have to find least integer which satisfies the inequation. So it would be nothing but minus 1. So my correct answer is option D. So this was quite simple. Now let us move to the next one. Now next one says that I have to find sum of integer values of x which satisfy absolute value of 2x minus 4 less than x minus 1. And this is something which is familiar to us. We have seen something like this where we have to find feasible region. Inequation is absolute value of 2x minus 4 less than x minus 1. Now mind you please, left hand side is non-negative and the right hand side no condition is given, but we can put from our side seeing the left hand side. So the right hand side has to be positive. So the moment I write x minus 1 greater than 0, I get x greater than 1. Now this gives me the feasible region where my solution lies. Means indirectly what I am saying, that solution does not lie in the region minus infinity to 1. So even 1 will not be included in the solution set. So my solution will start 1 onwards, if at all inequation has solution. So I simplify this. And how do I simplify? Given inequation is of the form absolute value of x less than a, solution will lie between minus a and a, same previous story. And from there, I realize that 1 minus x should be less than 2x minus 4 and 2x minus 4 should be less than x minus 1. Both should happen simultaneously. So I have two inequations now to solve. One gives me 3x greater than 5 and other gives me x less than 3. So I have written and, means common part we have to take. That gives me that x must lie between 5 by 3 and 3. So now we have three parts. One, inequation itself. Then I have feasible region and I have found now solution also. So feasible region will have to be cut now 5 by 3 to 3, which is our solution set. Now we want sum of integer values of x. So in 5 by 3 to 3, which integer lies? The only integer lies here is 2. So integer values, sum would be nothing but 2 because there is only one integer. So the correct answer is 2. So option A is the right answer. Now all 4 sums what we had today, they were of different type. Every question is dealt in a different manner. Basics we have not forgotten. That is what we have tried to apply. So you can try more questions exactly on the similar line. If required, find feasible region. Try to bring the correct, right kind of fundamental inequation what you have learned. And I'm sure you will get succeeded in solving the inequations. So when we meet next time, we will come with something new in the topic inequations only. Till then, stay tuned. Thank you.